With this stoichiometry calculation, I'd like to show you how to determine a theoretical yield and also how to determine the limiting reactant or reagent in an equation in this reaction here. Okay, let's read this problem. How many grams of ammonia can be produced from 11.8 grams of hydrogen gas and 24.9 grams of nitrogen gas? Now we're given a defined quantity of each reactant, but one of these will run out, will empty before the other. So one will be defined as a limiting reactant while the other is the excess reactant. And both of these quantities could potentially make varying amounts of ammonia gas. So our question here is, how much will actually be produced? This is what we call the theoretical yield. So let's start in with this calculation. The first thing we need to do is we need to determine who's the limiting reactant. When we find the limiting reactant, we will also find our theoretical yield. So let's take both of these quantities, 11.8 grams of hydrogen gas, and let's determine how much ammonia we could potentially make. That's what that theoretical yield is. And let's do this with the nitrogen gas as well. So the first thing we want to do is convert both of these grams to moles of their representative element. Okay, so we have our dimensional analysis: 1 mole of nitrogen gas, 1 mole of hydrogen gas. Okay. Now we're using the molar mass relationship to mole for these calculations. Okay, so for nitrogen gas we have a molar mass of 28.02 grams. For hydrogen we have 2.02 grams. Now what this will do, this dimensional analysis here will convert each of these quantities to representative moles. Now we will then take the moles of each, we'll continue with our calculation, and we will convert them to moles of the product, okay, using the balance coefficients. Okay, we must have a balanced equation because these coefficients, there's a 1 implied here, these coefficients tell us the mole ratio of the reactants and the mole ratio of the reactants to the product. So let's turn both of these to moles of ammonia. 2 moles of ammonia comes from 3 moles of hydrogen. And in regards to nitrogen, 1 mole of nitrogen gas leads to 2 moles of ammonia gas. Now, we're going to stop our calculation right here momentarily. We're going to go ahead and determine the moles of ammonium. The reason why I'm doing this is we first have to figure out who is the limiting reactant. Okay? So we're figuring out, based on these two reactant quantities, how much ammonia could we potentially make. We're going to get two values here. The two values of ammonia will tell us the theoretical yield. It will be the smaller value. So let's go 11.8 times 2, and then we divide by the quantity of 3 times 2.02, and we get 3.89 moles of ammonia potentially from here. Now let's do the same thing with the nitrogen. 24.9 times 2 divided by the quantity 28.02 times 1. So we have a potential of 1.78 moles of ammonia. Now, I went ahead and rounded these to 3 sig figs momentarily because of the original quantities were given with 3 sig figs. So both of these reactants give us varying amounts of ammonia that could potentially be produced. Well, the 1.78 moles is our theoretical yield. This is how much we potentially could make. Now, it's the smaller of the two values. We would never be able to make the 3.89 moles of ammonia from all of the hydrogen because our nitrogen quantity ran out. It emptied at 1.78 moles of ammonia. So we would never get that extra 2.11 moles of ammonia. We're going to have nitrogen, the 24.9 grams, be defined as our limiting reactant, and the 11.8 grams of hydrogen would be labeled as our excess reactant. Now, let's continue our calculation because the question asks how many grams of ammonia. So let's continue, but we're only going to continue with the 1.78 moles of ammonia potential because we would never produce the 3.89 moles. So now we'll take and we'll use the molar mass relationship again for ammonia. So 1 mole of ammonia, and the molar mass of ammonia, we take 1 of the nitrogen mass and 3 of the hydrogen mass, and we get 17.04 grams of ammonia as its molar mass. Then let's solve. So we have 1.78 times 17.04, and we have the potential, and again I'm going to round this to 3 sig figs, so I'm going to go 30.3 grams. 30.3 grams of ammonia. And this is our theoretical yield in grams.